Good day, grade 10 learners. Welcome to our second quarter lesson in science, specifically on physics. Studying the nature and properties of light under optics, our topic for today is refraction of light in spherical lenses, part 1. Our learning targets are differentiating concave and convex lens. Identify the three principal light rays. Describe the image formed in concave and convex lens and the application of spherical lenses. Let's now differentiate concave and convex lens. Concave lenses are also known as diverging lenses because the light diverges as it refracts through the lens. It is a type of lens that is thinner at the center than at the edges. Convex lenses are also known as converging lenses because the light converges as it refracts through the lens. It is a type of lens that is thicker at the center than the edges. In identifying the location, size, orientation, and type of the image formed by spherical lenses, we must be familiarized with the three principal rays. First is the principal to focus ray, or P to F ray. It is a ray of light parallel to the principal axis that is refracted, passing through the principal focus behind or in front of the lens. The second is the focus to principal ray, or F to P ray. It is a ray of light passing through the focus behind or in front of the lens that is refracted parallel to the principal axis. And lastly is the vertex ray, or V ray. It is a ray of light passing through the exact center of the lens, continue to travel in the same direction. Now that we have determined the three principal rays, let's move on to the image formation in spherical lenses. What do you notice in the image formed? The image formed by the two lenses are different. One produces a bright but smaller image of the candlelight, while the other produces an enlarged but inverted image. There are two types of images formed by spherical lenses. These are the real and virtual images. Real image is formed in front of the lens. It can be projected on screen and is always inverted. While virtual image is formed at the back of the lens, it cannot be projected on screen and is always upright. The image formed is dependent on the location of the object in front of the lenses. Let us find out the image formation in concave lens. If an object is placed at any point in front of the lens, the image formed is reduced in size, upright, in front of the lens, and virtual. The image is formed through the point of intersection of the principal rays. Since that the rays diverge in concave lens, extending the diverged light rays in front of the lens will determine the intersection, forming a virtual image. The image formed in convex lens is different. If the object's location is beyond 2f or twice the focus, the image formed is reduced in size, it is inverted, it is formed behind the lens, it is a real, and its location is between f prime and 2f prime. In this location, the converged principal rays intersect between f and 2f prime. If the object's location is directly at twice the focus or 2f, the image formed is same in size, it is inverted, it is formed behind the lens, it is real, and is located exactly at twice the focus behind the lens. In this location, the converged principal rays intersect beyond 2f prime at the back of the lens. If the object's location is between f and 2f, the image formed is enlarged in size, it is inverted, it is formed behind the lens, it is real, and its location is beyond twice the focus prime. In this location, the converged principal rays intersect beyond 2f prime at the back of the lens. If the object's location is directly above the focus, there will be no image formed, and it is at infinity. In this location, there will be no intersection between the converged principal rays. Now, if the object's location is between the focus and the vertex, the image formed is enlarged in size, it is upright, it is formed in front of the lens, it is virtual, and the image is formed beyond 2f in front of the lens. In this location, the converged principal rays will not be able to intersect at the back of the lens, so extending the rays in front of it will determine the point of intersection. Therefore, the image is formed beyond 2f in front of the lens. Thank you for watching. Stay tuned to our Refraction of Light in Spherical Mirrors Part 2, the Optical Instruments. For more video lessons, follow the Facebook page and YouTube channel of Exploring Physics with Teacher Val.